5-4 we're talking about here. There we go. Sorry. 5-4, we're talking about adding and subtracting like fractions.
When you draw the models, would it be subjective if you mess up?
Yes, actually, that's a good point, Bella. So when you're dealing with fractions, when you first started looking at fractions, you looked at a lot of pictures, or you had like what we call manipulatives. The manipulatives were exact, like they made it exact, but your drawings aren't exact. And I noticed this on the test. Did any of you here draw the fractions and compare those to tell me whether they're, and they were subjective, and it was interesting because I look at the drawings, not necessarily yours, but there are others. I look at the drawings, I'm like, they understood what it was, but their parts are not equal. So like one part is really big, these parts are small, so it looks like one is bigger than the other, but it's not. So yes, they're subjective. So the better you do at drawing, the better you will at comparing. But you guys are in pre-algebra now. So it's time to take those manipulatives and those drawings and apply it to theory, what we're going to talk about today. Okay, let's look at the first thing, and it's the first part of your notes. To add like fractions. So does anyone know or think they know what like fractions are? Jensen?
Fractions that have the same denominator?
Yes. Like fractions have the same denominator. So to add these like fractions, add the numerators and keep the same denominator. How many of you, just by looking at this definition, maybe realize that isn't it important to know what these words mean? Yes. Like, because if I say add like fractions, well, I don't know what a fraction is. Hopefully you do. Numerator, denominator. Do you know what these parts are? And if you do, this is not a hard definition at all. If I gave this to like a first or second grader, they have a mental blank. They have nothing to pull this from. You guys should be able to say, yep, I know fractions. I know that the top number is called a numerator, and the bottom number is called the denominator. So make sure that you keep that straight. Okay, and I'm going to use algebra to describe it. So every like fraction problem can be described this way with addition. A over C. Is that a fraction?
Yes.
Okay, and then I'm going to add to it B over C. Like, wait, you can't do that? What do these letters all stand for? Numbers. And do you realize that A and B are different numbers, but C and C are the same? So what I get as a result is, well, following this instruction, I add A plus B, whatever that is, and I keep it over the common denominator C. That's algebraically adding like fractions. So is that really hard to do practically? No. So I hope we can apply this. Yes, and thankfully, you know what's nice about this lesson? All the problems have common denominators.
Yes.
Are you kidding me? But don't worry. For those who want more of a challenge, 5-5 will give us that. But there is a challenge to this lesson. I'll give it to you. It'll come. The challenge comes. Yep.
If we get something like in the hands-on activity, 1/6 over 2/6 equals 2/6, we have to simplify it.
Yes. Always simplify your answers. And actually, what a great question to ask as we look at example number 1. All right, let's look at how we work these out. Example 1A gives us S equals 3/4 plus 3/4. Okay. Are we adding fractions here? Yes. Are they like fractions?
Yes.
Why are they like? Same denominator. All right, so what does it say to do? Add the, so what's 3 plus 3? 6. And then keep the, so it's 6 over 4. But that answer is improper and it's not reduced or simplified. So there are two things I need to do to this fraction to make sure it's correct, completely correct. And really, you can do it either or first. You can do it either or. All right, Emma Grace? All right, good. Divide this by 2 over 2. What does that give me? 3 over 2. But that's not my answer still. That's still improper. I reduced it, but it's still improper. Next step. Yes, Elizabeth?
You can make it a 1, like a 1 and a half.
Okay, I get my final answer of s equals 1 and a half. S equals 1 and a half. Now, how in the world did I go from 3 halves to 1 and a half? Some of you, if you can do it mentally, do it. But how did I do that? Like what process? Sydney?
You see how many times the denominator can go into the numerator?
It's basically a division problem. 3 divided by 2. How many times does 2 go into 3? Once, with a remainder of 1. So I get 1 with a remainder of 1 over the denominator. Okay, so we'll go through that many times. Yes, sir?
You could also make it a mixed number and then reduce it, right?
Yes. So like here, if I had 6/4,
Yeah.
you can make it 1 and 2/4,
Yeah.
and then 1 and a half.
Yeah.
Yep, you can go either mixed and then simplify, or simplify then mix. Yep. All right, let's look at B. Man, these are nice, right? Nice, easy practice problems. Oh no. B is y equals 3 and 2/5 plus 4 and 3/5. Oh man, this is so cool. I'm going to do something to this problem after I give you one more piece of info, and then this is going to review whether you listened yet to yesterday's lesson, okay? All right, so I have my problem right here. Does anyone know what a mixed number even is? What is a mixed number? It's a number that's mixed. Well, what does that mean? Marissa?
A number that's a whole number and a fraction.
Okay. Anyone want to add to that? That's good. Add or modify? Go ahead.
And it would also be a rational number.
Okay, good. Oh, good. So rational numbers, so that's review. Good. Rational. We call a mixed number a whole number and a fraction combined by addition. This is 4 plus 3/5, which is 4 and 3/5, right? And this is 3 and 2/5, 3 plus 2/5. It's an addition problem right here, okay? If that's so, watch what I do here. Ready? See if you can tell me what I did. I used 2 operations that hopefully you can kind of, maybe, sort of remember. Michael, can you give me one of them? Okay, how do you know it's associative being used here?
But you changed the groupings.
Okay, I changed groupings. So that is one. I have grouping here and grouping there. And then I use another property. Jack? Close. Doesn't it look like it? If I have multiplication here, it would be distributive. But it's not distributive necessarily, Jensen? Okay, yeah, associative. We got already here. Yes, Sydney? Commutative. Okay, I said this was addition, didn't I? And that's addition. And that's addition. So can I switch the order?
Yes.
And then group together? You don't have to write this out, guys. But you do have to add the whole number parts, which gives you 7. And then add the fractional parts, which gives you, close, I get 5 over 5. Now, is 5 over 5 proper?
Maybe.
Now, how many of you would agree that 7 and 5/5 becomes 8? How many of you agree with that? You know why you agree with it? Because this is 7 plus 1. Yeah, in the form of 5 over 5. Very good. Do you guys understand that? Yes.
Can you also
Yeah, time I shoot.
uh,
Don't mind me.
can you just make them like regular fractions, like convert them into?
Oh, so make the do the multiply then add, make them improper then add. You technically could, yes. I'm going to say if you know how to do that, do that. Mm-hmm. Okay, you guys good with that? Do you guys agree that this is addition? It better be, because that's how it works.
I couldn't really
Okay.
see the words. So I just
I'm sorry, Bella.
rational,
I'll move out of the way. How about that? Page 241. I want you to work out number 5 real quick. Number 5 on page 241. 4/7 plus 5/7 equals m. And that equals y. Okay, let's go ahead and work that one out. I want a simplified answer that may be in mixed number form. Okay, I'll give you just a few more seconds. All right, Sophie,
I have an answer.
go ahead.
Okay, so you would add 4 plus 5 equals 9 over 7, and that's an improper fraction. So I divided 9 by 7, and then I got 1 and 2 sevenths. M equals 1 and 2 sevenths.
1 and 2/7 equals m. How many of you got that? Okay, how many of you got to this point? You got 9/7. Okay, and then after that you divide. So this is like, if you're not sure how I'm going from here to here, this is what we're doing. We're doing in our head 9 divided by 7. How many times does 7 go into 9? Once. That's 7. I get a remainder of 2. So this shows me my mixed number 1 and 2/7. Okay, that's the pattern I'm going through. You guys okay with that? Yes, ma'am.
Isn't the bottom always going to be the numerator of your division problem?
So how about this? This number always goes in the box.
Yeah.
Yeah.
But like, so you got 172, but doesn't the 2 or whatever number's always down there, it's always going to be the numerator?
Yeah, okay, I see what you're saying. So this is always the whole number part, and this is always the numerator, and that's always the denominator. Yep, you definitely can take that to the bank there. Number 6. Go ahead and do number 6, please. Make sure that your words are not being a distraction to others, because we want to show love to others in what we do. So this is 1 and 2/19 plus 17/19, and that equals A. So remember, add the whole number parts, add the fractional parts, combine until a final answer equals A. All right. Do you have a question? Yeah, go ahead, Marissa.
Mr. A, does it matter if the variable goes first and then the answer?
Yeah, so your answer could be something equals A or A equals something.
Okay, I didn't know
No, there's no preference on that. Only time that gets a little tricky is with inequalities. We'll talk more about that later. Again, Emma Grace.
2.
All right, good. 2 equals A or A equals 2, that's it. How many of you got 19/19, which is a big fat
1.
1, and then 1 plus 1?
2.
2. That's how you got it. All right, good. Whew. These are easy, aren't they? All right, time to get to the tough part. Second part. And maybe it won't be that tough, but it's the tougher part. To subtract like fractions. Subtract the numerators and keep the same denominator. So doesn't that sound familiar? Sounds just like addition. Wait. Addition and subtraction sound very familiar. Huh.
Wait,
Interesting. Okay.
are we
Yeah.
going to get into the negatives today?
Yes.
Yes. Yeah. Okay, and to say it algebraically, we're going to use our expression A over C, and this time minus B over C. Can anyone give me what that final expression would look like in algebra? Caroline? A minus B over C. You know what's kind of cool, guys, as I think about it? Sometimes things come to my mind. I remember when I first brought up variables and saying it's going to make math easier. Do you remember that, like at the beginning of the year? Yeah. And I could tell that it was skeptical, but really, I'm proud of you guys and how you're already thinking algebra. We're pre-algebra is like a bridge from arithmetic to algebra, and we're like in the middle of the bridge. And soon we're going to get to the tough part. Think of those bridges, that are across like this huge divide, and the bridge is kind of shaky, and some steps are broken. Okay, so you're going to feel like that sometimes, but you're doing well so far. Hopefully you have a guide and a bungee cord that can help you just in case. Okay, yes, ma'am. Callie?
What is it when you do stay, change, and you flip the fraction?
That's when you're dividing fractions. So we'll get to that later, but yeah, dividing fractions. Yes, sir. It's an emergency. Okay. All right. Let's look at example 2 now. And this one is y equals 7/15 minus 28/15. This is similar to those decimals. All right, you have 7/15 minus 28/15. Do we have like fractions?
Yes.
Yes, that's good. So what do you do with the numerators in this problem?
You subtract.
Subtract them. Wait, you're going to do 7 minus 28? You can't do... Oh, wait, you can do that. And what do you get?
Negative 21.
Okay, so I end up with negative 21 over 15. Hold on. Am I done?
No.
So soon I'll get that y. But do you guys see how I got negative 21 over 15? Do you guys see that? Yes. Okay. What do I do here? You want to change it into its simplified form. And if it needs to be changed to a mixed number, you will do it. So I think honestly simplifying then changing to a mixed number is easier, but you can go either route. Okay, Elizabeth?
You get 1 negative second over 5.
Okay, isn't it tough to say? Like, where does that negative go? That's a tough question. Here you go, guys. I'm going to teach you. This is getting into algebra. Ready? This number is the opposite of 21/15, isn't it?
Yes.
So I'm going to do this. Instead of writing that negative by the 21, I'm going to write it next to the fraction bar. And you're like, okay, why would I want to do that? Yeah, because really what you want to think of it is this. Can you simplify that? All right, and then what do you have to do at the very end? Add the negative. Because it's the opposite of 21/15. So, well, we're not done yet. Yeah, we're still going to figure out. What do you guys do here? I'm going to simplify it. How does it simplify?
You divide it by
3 over 3. So what do I get here? 7/5. And I still have that negative. Ooh, negative. And then I have to change it to a mixed number. It's going to be negative the whole time. It's got to be negative because that's what it is. And then what do I get, John? Okay, it'd be 1 2/5 negative. Equals, what's our variable? Okay, the reason it's going to be negative 1 2/5 is because of this. Okay, what is 21/5 simplified and changed it to a mixed number? What would 21/15 be? 1 2/5. What's the opposite of that? Negative 1 2/5. Sorry, I keep saying the wrong 5 and 15. But you guys see what we got there? That, you got to think through it straight. All right. Uh-oh. Example number 3. Yes, ma'am. Go ahead. Yep.
Okay, so I know we're trying to get rid of them all, but I'm just wondering, okay, so you have positive 1 2/5. I can imagine what that would look like, but how would negative 1 2/5 look like? Say if you had negative 1 2/5 like a pie or something.
So that's, okay, so now you're going to go to an application with algebra, and this is how I have to describe it. Positive 1 2/5 means you have 1 2/5 of a pie. But negative 1 2/5 would be like you owe somebody or something 1 2/5 of a pie. So you don't have that, you need to give that to somebody. Like You gave me 1 2/5, and I owe it back to you. So I owe you 1 2/5 of a pie. You can use that a lot with finances, like I owe money instead of having money, and that happens. Okay, but good question. That's a good question. And this problem says find m plus n if m equals, example 3.
3 and 1 6.
3 and 1.
Equals -1 plus n 5 6.
So again, I have this, I owe this, if you want to think of it that way. Or like temperature, right? You're either above 0 or below 0. So you have negative that it can apply in different ways. But here, I'm going to add these two together. So I have 3 and 1/6 plus -1 and 5/6. You guys agree that's how I write it? Yes. If you have a plus then negative, yes. But there is technically a way to make this into something else. Subtraction. You can make this, let's see here. Ready, guys? Stay, change, opposite. Do you guys remember that? So 3 1/6 minus +1 and 5/6. You could do that as well. But we're going to keep it like this. Well, you know what's cool? You're going to do it the same way anyway. So that, yeah, maybe it looks easier, but it's still, the process is still the same. All right. Here I'm looking at this problem, and I'm thinking, I don't even know what to do. Like, I don't even get this problem. Let's estimate. So what would 3 1/6 round to? 3, right? Isn't 3 and a 6 just about 3? What would -1 and 5/6 round to? -2. So what would this be?
1.
Okay, just be 1. That's an estimate. That's not the actual answer. Okay, so I'm going to keep that 1 up there. My answer should be pretty close to +1. But let's see here. I have here, and this is the hardest part. I have a positive and a negative being added. So how do I deal with them? You subtract them, which is what you're going to do. So I'm going to do 3 and 1/6. I'm going to give me some space here. 3 and 1/6 minus 1 and 5/6, right? Okay. So you're going to subtract the whole number parts and the fractional parts, but I have a problem. Error. Okay, everyone could do 3 minus 1, right? Pretty good. Okay. 1/6 minus 5/6. That gets tricky. So please listen to me right now because this is the hardest problem of this lesson. Ready? I could do 3 minus 1, no problem. But 1/6 minus 5/6, I'm going to get a negative, right? So I'm going to get a positive number and a negative number, and that gets tricky. Don't make yourself go through that heartache. Change this number so that I can get a fraction that can subtract 5/6 easily. I'm going to rename this fraction. How? You can't just change the name. You can't. Change the close of the same value. Caroline? Okay, you could do 19/6, and then you could change that to -11, or sorry, -11/6. Okay, that could work. And if you could do that, do that. But there's another way to rename this mixed number, and I hope you'll be able to see it. Tristan, what do you think?
Okay, so don't you make the 3 a 2?
Okay, make this a 2.
Yeah, 2 is
Yeah,
the same
and
as.
do you add 2 to 1 or 6 to 1?
You add
Gotcha.
6.
Okay, when I take away 1 from here, it becomes 2, right? I'm taking away 1. But when I add 1 here, it has to be in the form of 6 over 6, right? Because what's 6 over 6?
1.
So I get 2 and 7/6. So hold on. I'll do it again.
Oh, I get it now.
Let me ask you this. Is 3 and 1/6 the same as 2 and 7/6? Same value.
Yes. No.
Same value.
Yes.
I like the doubting. And that's okay if you doubt. They are the same value. Now, you're like, why would I even want to try this out? Well, let's see. What's 2 minus 1? 1. What's 7/6 minus 5/6? That would be my answer after I simplify it. So it's 1 and 1/3. Okay, let me show you what most of us are very tempted to do. Ready? Can I show you what we're tempted to do? It's this. I'm going to go back to the original problem. And again, I'm trying to help you out. So 3 and 1/6 minus 1 and 5/6. All right, we think, all right, do 3 minus 1. Oops, and that's 2. That's 2. And then 1 minus 5/6, does anyone know what that would be? It'd be negative 4/6. So we get this number right here. Does that look kind of tricky to anyone? No? It looks to me, it's like 2 and... You don't say 2 and negative 4/6. Oh, sorry, 2 and negative 2/3. Is that a mixed number? No. Oh, I get it. Negative 2 and 2/3. Is that the answer? No. The answer is there, but it's harder to see. It's 2 minus 2/3. All right. So what's 2 minus 2/3?
1 1/3.
It is 1 1/3, but isn't it really hard to see it here? It is 1 1/3, but it's not easy to do it that way. Don't do it that way. Do it this way. Rename. All right, so I'm going to help you rename it real quickly here.
Can you show us the way with the improper fraction?
Not today.
That would be like subtracting, adding, subtracting.
And listen up. The reason I'm going over this again, let me give you this little illustration. In Algebra 1, I spent 2 chapters on graphing lines. I've just spent 2 chapters. They just had their test yesterday. And then this chapter, you know what I do? We go over the shortcut of graphing lines.
What?
There's a shortcut. You just do this and you're done. They had to make these tables. They had to pick their points. They had to put those points on a graph or on a coordinate plane, then connect them with a line. And all they had to do is look at this number and that number. They're done. Why would Mr. A do something to them so cruel? Yeah. What do you think, Tristan?
Because I think you want them to understand the process of how you do it.
I really do. And then now when they see that easy process, they're like, this is another thing. I'm so thankful we don't have to do the table. I'm like, yes, be thankful you don't have to do the table. But how did we get that little shortcut? It's from this information that we learned in 2 chapters. 2 chapters to make it a simple process. So try to do it this way, and if you struggle, I will help you out. Okay, your homework tonight.
No, can you go over another problem like that?
I'll go through another one. Yep. Is 13 to 31 odd? Sorry, 13 to 31 odd, and then I think it's just one more. Yeah, 42.
Can you do the math to figure out how many problems that is?
Yes, ma'am. Just a moment.
Don't count.
Bye-bye, Swivl.